Hello everyone and welcome to Pentagon. Today I have for you a rather striking problem. Let z be a complex number satisfying z plus 1 over z times z plus 1 over z plus 1 equals 1. Evaluate 3 times z to the power of 100 plus 2 over z to the power of 100 plus 1 times z to the power of 100 plus 2 over z to the power of 100 plus 3. This may seem daunting to you, but I can guarantee that the solution is quite elegant. So please pause the video here if you'd like to try and solve this yourself. Alright, now the first thing we want to do is take our first equation z plus 1 over z times z plus 1 over z plus 1 equals 1. And we want to expand this, and by expanding it, we may be able to find a pattern in our equation. So let's expand this together. Z times z is z squared. Z times 1 over z is 1. And z times 1 is z. Next, 1 over z times z is 1. 1 over z times 1 over z is 1 over z squared. And 1 over z times 1 is 1 over z. And this is all equal to 1. Next, if we cancel out the 1's on either side, we get that z squared plus z plus 1 plus 1 over z plus 1 over z squared equals 0. Now, we don't really like having this denominator of z squared in our equation, so let's multiply both sides by z squared. And so by doing that, we get z to the 4th plus z cubed plus z squared plus z plus 1 equals 0. Now here we can find our pattern. Each term in the left side of our equation is decreasing by 1 degree. Additionally, this side of our equation may look familiar because it is in the form of a factoring formula for a very specific polynomial. And the formula is as follows. X to the n minus 1 equals x minus 1 times x to the power of n minus 1 plus x to the power of n minus 2 plus, and so on until plus x plus 1. Now, as you can see, this portion of the formula is analogous to the left side of our equation. So let's substitute this side of our equation into this formula and rewrite the formula thus. We would get this factor becomes z to the 4th plus z cubed plus z squared plus z plus 1. And consequently, the other factor should become z minus 1. Finally, we notice that the final polynomial of this formula should be z to the 5th minus 1. All right. Now let's solve for our desired factor by dividing both sides by z minus 1. So we get that z to the 4th plus z cubed plus z squared plus z plus 1 equals z to the 5th minus 1 over z minus 1. Alright, now what we can do is substitute this value into our original equation. So back to our question, we'd get that z to the 5th minus 1 over z minus 1 equals 0. If we multiply both sides of our equation by z minus 1, we get that z to the 5th minus 1 equals 0, and that z to the 5th equals 1. This is extremely important for solving our question because the expression we're asked to evaluate has the number of z to the power of 100 in it. But what can z to the power of 100 be written as? Well, it is equal to z to the 5th to the power of 20. And since we know that z to the 5th is just 1, this simplifies to 1 to the 20. And we know that 1 to the power of anything is 1, so this is simply equal to 1. This makes solving our expression a lot easier. So now we have everything we need to solve our expression. Let's write it over here. Three times z to the power of 100 plus 2 over z to the power of 100 plus 1 times z to the power of 100 plus 2 over z to the power of 100 plus 3. And we know that z to the power of 100 is 1, so let's substitute 1 in for every z to the power of 100. In the first group of parentheses, we have 3 times 1, which is just 3, plus 2 over 1, which is 2, plus 1, times 1, plus 2 over 1, which is 2, plus 3. And this simplifies to 6 times 6, and our final answer is 36. Thank you for watching this video. If you liked it, please consider subscribing to our channel. Thank you all, and I will see you in the next video.